Let me make some space. Can see, right? Okay, Daniel went on a journey 90 kilometers, and then he took X minutes for the first 40 kilometers. Write an expression in terms of X for his speed in kilometers per hour. So they gave you a hint on what your unit should be. So this is 1. So the first 40 kilometers, if you want speed, is D divided by time. So part A, the speed for the first 40 kilometers will be 40 divided by the time of X minutes. So the minutes, you got to convert it to hours first. So you divide by 60. So it will be good for you to simplify the expression. So it's 40 divided by X over 60. So you do a keep change flip. So actually it's a 2,400 over X kilometer per hour. Okay, so take note of the units. Yes. You can. Okay, so make sure you convert the units to the correct one that is specified. Otherwise, it will be wrong. Okay, then second part, it says Daniel took X plus 15 minutes to drive the rest of the journey. So what is the speed for the second half? So same thing. Distance left is 50 kilometers now because total up to 90, right? And then the time taken is X plus 15, but you got to convert it to hours. So the second half, you can also simplify. Okay, wait, I squeeze a bit. So that's a 3,000, I believe. Okay, so this is part B's expression. This is part A's. And then it says the speed for the first part of the journey was 9 kilometers per hour faster. So faster means it's a bigger magnitude, right? So this is a faster speed as compared to this one. So you use A minus B. Their difference should give you 9. Okay, so this is what they are trying to say. So put it in 2,400, 3,000, then equals to 9. So this is the expression I need to see. The rest is just your algebraic simplification. Do you need me to show you how to get there? Or it's okay? It's okay, right? Then solving, I just want to emphasize. Okay, wait, I cover this part. Should be okay, right? If not, y'all cannot see. Okay, I just want to emphasize that this one, this next part here, when part D, they ask you to solve, right? Whenever they ask you to solve the quadratic expression that you have been asked to show, in this case, this one important because when I was marking your work, some of you are losing marks here and there. Okay, so part C asks you to show the quadratic equation, and then part D asks you to solve. When they ask you to solve, they ignore the context of the story. That means they don't care whether this X represents speed, length, time, or anything. So when you solve, there's always 2 solutions. Don't reject any one of it. Because you are just solving, you solve, you give me the 2x values. Don't reject here. The rejection comes in the next part where you need to use one of the solution to continue. Okay, so part D, be careful. Don't reject your solution here. You reject, you lose one answer mark. Okay, so solving, I believe you wouldn't have any issues with that. It's just quadratic formula. Okay, and then please remember your roof. Okay, average speed is total distance divided by total time. Okay, so total distance, total time Yours is 90 kilometer for the total distance. Total time is your x and then your x plus 15. Right? Remember to convert to hours. So the x, you will choose the one that is correct. There's two answers there. One is positive, one is negative. You will reject the negative one because speed is a scalar quantity. It has no direction. It shouldn't be negative. In science, you learn that, right? Scalar, vector quantity, got direction, no direction. So for speed, there's no negative speed, just like you don't have negative length. Unless you cross to another dimension. Okay, then I leave you to go and write the answer. So pick the one, pick the correct one here, and then you sub it in here. So if you want, you can reject at the start here. Okay, and then plug it in. Don't reject at this instance, otherwise you lose marks. Yes. Zoom out, cannot see other part. Okay, so it is here. Okay, so if you read from the diagram, it is just x equals to half. But some of you say, oh, how can you be so sure it's exactly there? Is there a way to be very, very sure? The answer is yes. You need to find your x-intercepts. So when you want to find x-intercept, you sub y as 0. And then you try to solve it. So what you can do is, you can take out x as a common factor. And then half x is equals to 0. 1 minus x is equals to 0. So x is 0, x is 1. So these are your two x-intercept. Line of symmetry halves these two. So that's why you get half. But do you have to work so hard? No need. You just give me this, you get the 1 mark already. Okay, but you cannot give me half. You must give me x equals to half. It's an equation. It's a vertical line. Don't give me a half there. Okay, so this is just for you to check how we get there. Okay, part B. Okay, I want you to have a very close look at our equation. This red curve is given by this equation. And if you look closely to this, does it look like the same as what we have up there? Except what? Except the half. So your mission is to make sure that whatever they ask you to solve must look like your equation. So what you need to do is to multiply by half on both sides. Okay? So if I half it, okay, if I half it, can you see that now? This is my curve. This is the red curve that you have drawn. And they told you that it is equals to y. Right? So they are asking you to intersect the curve with this straight line. Y equals to -2. Okay? So on the left, you have gotten your curve. They want it to equate to the line y equals to 2. So how does the line y equals to 2 look like? Like this or like this? Like this, right? Horizontal line. So go and draw the line y equals to -2. Here. Okay, once you draw the line y equals to -2, Then the two intersection will be where your solutions are. Okay, if you read exactly on your graph, mine is not exact because my pencil very thick, right? So what is your intersection here? Is it minus 1.6? Mine may not be accurate. Maybe yours will look better. This is 2.6. Is yours 2.5? About. Draw the horizontal line and tell me where it intersect. I need the exact one. Draw the line y equals to 2 and see where it cuts your curve on the grid. Is it same as mine? What do you have?
Yeah, same.
Same, huh? Okay, that means it's accurate. So your two solutions are this. Okay, but the question say determine the number of real roots. Actually, you can just tell me there's 2. They never ask for the exact solution, but we are going above and beyond. So these 2 solutions are what we have, but the number of it is just 2 of them. Yes. Okay, for curves, usually we will accept a range of values subjected to a bit of error. So it need not be exactly at minus 1.6. If some of you write what, minus 1.55, minus 1.5, sometimes you fall in the range, we will still give the mark. Okay, but if it's a straight line, we won't. Curve, we will accept. Okay, next one. I have a curve. This is the curve. The green one. This is the line. The red one. And then they say, oh, this one not very relevant. Okay, never mind. If I ask you for the 2 solutions, you just have to go and read for me. But this second part asks you why the curve does not have some solutions when it's at certain values of k. Okay, so this one, pay attention closely. Look at this. Can you see that this is your curve? The same expression that you see here. It is your curve. Okay, and they say it's equals to y, right? So they set it to be equals to k. So y equals to k is again another horizontal line. So they want you to see that. Okay, if I take out my ruler, can you see? If I have a horizontal line, they ask you, is there a value of k where there will not be any solutions at all? Where? Where? Below the minimum point, right? So if my k value is exactly at this lowest point here, there will be one solution. I need it to be strictly smaller than that value. So if I read carefully, it seems to be that it is at, the scale very difficult, right? Every 2 box is 1. So this is minus 6. Okay, let me try to read this. This is minus 6. Let me thin my pencil. This is negative 7. This is negative 8. Negative 9. So it seems to be that it looks like it is at negative 8.25 like that. Something like that. Right? The lowest point. So they say, explain why the equation does not have solutions for some values of k. So you can say that for y equals to k such that k is less than negative 8.25. Okay, that means as long as k is lesser than negative 8.25, it falls below, right? The straight line y equals to k will not intersect the curve. Okay, therefore no solutions, no real solutions. So they just need you to show this understanding. Of course, I can change the question to explain why the curve has two real roots or two real solutions for some values of k. Then you can tell me for the k greater than minus 8.25, it will always cut the graph at 2 points. That's why two solutions. So we can change the question asking similar stuff. So you must have a strong understanding. O-level likes this, which means teachers like this also. So you all must prepare.